Hey, what's going on, guys? Vinnie here from CreationAstronomy Now.com and Creation Company with my brother Joe.
How do I start that? Oh yes, welcome to the Creation Astronomy Now Podcast.
Yes, hey guys. Hey, what's going on, guys? Vinnie here from CreationAstronomy Now.com and Creationist Company here with my brother Joe.
Welcome to the Creation Astronomy Now Podcast, the show that spends 5 minutes every episode to try to think of a decent pun.
Yeah, we have a lot of trouble with that, but coming up with good jokes is one of our most important jobs. It's very important work that we do here on the Creation Astronomy Show. But today, we are very excited to present to you another interview with somebody I've been wanting to interview for a while. And finally we got to it. It's funny, I was a little more nervous this time than usual.
And I was a little bit more relaxed than usual.
Which is kind of weird.
It was kind of annoying though. We were trying to talk to him over the phone, you know? We never done this before. Generally we just use Skype or Google Hangouts. And so we could just call him on our phone, and we have a cheap phone. And the speakerphone doesn't work very well. The first one, it worked, but the quality was terrible. And so we thought, well, we'll try the other one, and it would not stay on. It kept hanging up on him. So we thought we'd just have to use the computer phone, and if that didn't work, the world would end.
So yeah, it came really close to disaster. But fortunately, we all came together as a team to figure it out, and we were able to interview Dr. DeYoung, talking about the moon, because recently we got to see that lunar eclipse. Speaking of which, we just got a image submission from Jared Bowens. Joel, pop that up on the screen
Yeah, just
now.
pop that up right there.
And if you want to submit some of your own images of the eclipse or whatever, then you can do that under the Submit Your Astro Images under the Observing tab. So, I guess without further ado, let's jump into the interview. Welcome back to the super amazing interview section where we bring on informed experts to steal our show and blow your mind. And today, we are doing a new experience. We're trying to interview via the phone, which we've never done before. So as you guys know, when we haven't done something before, it a lot of times ends in a disaster. But hopefully that's not the case today. So today we have on the show Dr. DeYoung. He's a professor at the Grace College in Indiana. He has a PhD in physics, and his courses at the college include physics, mathematics, and astronomy. And Dr. DeYoung, before we get into this moon stuff that we want to talk about, we've given some bio already both now and in the intro to the podcast, but could you just real quick tell us a little bit about yourself, how you got into astronomy, and how you got involved in the creation science field?
Well, man, I do live here in Indiana. My background, I have an undergraduate engineering degree and then went on to grad school in Iowa. I've had a whole career here at Grace College in Winona Lake, Indiana, teaching physics, calculus, and astronomy is a side interest. We have courses in astronomy as well. We try to do a lot of stargazing with that course. Also have a special interest in apologetics. That's a fancy word for the study of Bible and science, or creation evolution. I like to write and speak in that area, writing articles and books, putting on seminars, so I have a lot of interest there.
All right, now I understand you're the president of the Creation Research Society, so could you tell us about some of the work you do there?
Well, the Creation Research Society, just for the initials, CRS, is the oldest creation group in the country. It's a society. It's a group that you actually join. We've got about 1,700 members around the world, mostly professional scientists, guys and gals, but anyone can join the society as well. Our website is creationresearch.org. And we carry on research. We have funds, and some people make application. When you get into the creation position, there's lots of interesting work to do. We have a laboratory that we own and operate out by the Grand Canyon, where visiting scientists can stay when they're working on desert plants or the Grand Canyon or space studies. This CRS group also, we produce a technical quarterly, and we also have a magazine called Creation Matters. So we've got a number of things going. It's kind of a neat group to be a part of.
Cool.
So you're well known among the creation science field for your lectures and writings on the moon. But why do you find the moon so fascinating?
Well, I do enjoy exploring the moon from Earth, of course. It turns out, of course, that the moon is our nearest neighbor in space. It's about 250,000 miles away. We've been to the moon. We did go back there in the 60s and 70s. 12 astronauts walked around on the moon, so there's been a lot of study there. So when it comes to space, this becomes the first step of a near object to explore. When it comes to the origin of the moon and what it's like, it's just the stepping stone. It's the place to begin with exploring outer space.
Yeah. I recall when I was a kid, I believe I was 12 at the time, I got the DVD, which I don't have here. I should have. I'll show it in the intro to the podcast. Remind me to do that.
Okay, yeah.
But anyway, it's just really fascinating to me, and it's so true. We know so much more about the moon than almost anything else. The only thing that comes close to it, other than outside of Earth, of course, is Mars, which has had a lot of exploration. And for those now, there are some of us listening to this of all ages and education backgrounds. But for those listening who are just like novice astronomers, could you tell us how the moon's orbit and tide works? And the Earth's tide?
Well, certainly. Of course, the orbit, the moon circles the Earth about once a month, 29 and a half days actually, as it goes through its phases that we've all watched and enjoyed. The moon is interesting. It does always keep the same side toward the Earth. It has a backside, a hidden side that we don't see. It's just kind of locked in, and it's been that way for a while. The moon does not escape the Earth because of our gravity force. We hold on to the moon. It's almost like a ball being swung at the end of a string, although with the moon, that gravity force amounts to trillions of tons of force. We pull on the moon. It's actually in constant free fall toward the Earth. It does feel our gravity falling toward us, but it also has this tangent speed, this orbital speed, so it kind of falls around the Earth without getting any closer to us. Since we pull on the Earth, by Newton's third law, forces always occur in pairs, and so the moon also pulls back on the Earth, and that causes the tides. Again, it's that huge number, billions of tons of force, which pull on the oceans, making the water rise and fall. It also pulls on the land. Indiana, Illinois, the land itself rises by a foot or more as the moon moves overhead. So these tides are tremendous. It's all due to this invisible gravity force, which frankly we don't understand, but it's a faithful force. I've sometimes called it the Elmer's glue that holds the whole universe together, including keeping the moon in its orbit and keeping the Earth circling the sun.
Okay, so can you explain to us why the moon is important for life on Earth?
Yeah, what good is it? Why should we have the moon here?
Why do we have the moon?
Well, a good question. What's the moon good for? Would you miss it if it was gone? Has it done anything for you? I like those kind of questions. And it's something I enjoy about the creation viewpoint, because once you say that the moon was put in the sky, then it's not just a chance, accidental thing, but there are reasons. And so when you think about the moon, what does it do for us? Now, maybe the first thing that comes to mind is it's a nightlight. Some nights there's a full moon, other times a partial moon or no moon at all. And certainly throughout history, that moonlight has been very important to guide one's footsteps and to guide explorers. Now today, of course, we've got street lights and flashlights and maybe don't depend so much on the moonlight here in the U.S., although other countries do. And I sometimes wonder how much the moonlight does even for the germination of seeds, an area that has not been explored very thoroughly. So the moon is a night light. Now, the moon is so faithful in its orbit, you can tell time by the moon. It's a clock. You can tell direction. It's a compass. It just goes on and on, those kind of useful parts of the moon. And you can tell the seasons by the moon. And we've learned in just the last 20 years or so that the moon is even responsible for our seasons. without the moon, the Earth's axis, we're tilted at 23.5 degrees, and that's what gives us the seasons. That angle could change. The Earth would wobble. It's the moon that stabilizes our tilt. Without the moon, we might go from winter to harder winter. So give thanks for a moon that keeps seasons rolling on by. There's something else about the moon that's fascinating. I believe that the moon is responsible for the very air that we breathe. Now, the moon causes the tides, keeps the ocean stirred up. Of course, there's a lot of life in the ocean. You've got fish, you've got plants. You've got lots of plants in the ocean. The floating plankton called the grass of the seas. You have the kelp forests in the shallow areas. Now, we recall that plants breathe the opposite of us. They take in CO2 and they give off oxygen. Well, there are a lot of plants in the ocean. Current estimates are that sea plants make half of the oxygen in our air. So I'm thinking of this scenario. If there was no moon, there'd be no tides, and the ocean currents, the ocean motion would be much diminished. In fact, that would make the ocean go stagnant, and all the life in the ocean would die. You wouldn't want to go to the beach anymore. It would smell. It would be septic. There goes the plants. There goes the oxygen. There goes us. Our very breath depends on the whole system of the moon keeping the earth and the oceans healthy.
You know, it's amazing how, perfectly balanced our entire universe is. And then the evolutionists say it just happened by chance. But speaking of the light from the moon, remember the when we were watching the lunar eclipse, we actually got up an hour early, but the moon was just so bright. It was almost like daylight. I could just imagine, harvesting the fields like they did in the olden days by the light of the full moon. It's pretty interesting to think about. But speaking of the moon, there have actually two interesting moon occurrences, one that really is kind of offshore for this podcast. The first is that, of course, the lunar eclipse, and in fact, we got our first user-submitted image, and future Joe, pop that up on the screen, Joe, who's editing this podcast. Also, we got to see the lunar eclipse. It was really cool just watching it, and I hope a lot of people got to see it because it was a phenomenal event. We'll get to talking about lunar eclipses a little later. But another thing is that I just found out there's a 3DS remake of The Legend of Zelda Majora's Mask.
Okay.
But it got me thinking, what would happen if the moon started working its way back to the Earth over the course of 3 days? So I did a little bit of equation. I'm not the best at physics. I'm still studying it, but I was able to find out a little bit of stuff. In fact, I didn't bother figuring out how the moon's if the moon started heading towards the Earth, of course it would speed up as it got closer.
Yeah.
But so I figured out that by day one, the gravitational pull between the Earth and the Moon would be double. So, Dr. DeYoung, since you're the expert, over the course of these 3 days, by the first day, what would we be seeing on Earth if the Moon's gravity was doubled?
Well, I'll have to say, first of all, that the actual occurrence in space is the opposite of what you are describing. The moon is spiraling outward from the Earth and getting further away from us each year by just by several inches. So you're proposing a moon that would be approaching the Earth. That's interesting. Gravity certainly would increase. Tides would increase, as you say, by the gravitational laws. This varies as the inverse square of the distance, or maybe even stronger than that, so there's some other factors involved. My goodness, after 1 or 2 days with the moon approaching the Earth, it would be interesting. The tides would become gigantic. Tsunami would sweep over the land if the moon got anywhere near the Earth. In fact, this would heat up the oceans. They would come to a boil. You couldn't survive on the Earth. And if the moon got too close to our vicinity, within what's called the Rausch limit, the moon would be broken up, it would disintegrate, the tidal forces of the Earth, the gravitational forces, would rip the moon apart, and we would end up having a ring around the Earth, something like Saturn's ring. The bottom line here, you cannot have the moon anywhere near the Earth, or you have too much heat, you have too many waves, and you wouldn't even have a moon anymore.
Yeah, I think by dawn, the final day, you would have met with a terrible fate. That's a quote from Majora's Mask, by the way, guys.
Yeah.
But anyway, let's now
So there's one thing, that game's not very scientific.
No.
Because at the end, everyone's sitting there, and the moon's like only 10 feet above the Earth, and it's going down.
Yeah.
Not scientific.
Video game logic. Gotta love it. But anyway, it's amazing how perfect the moon is, and I want to get into some of the evidence of the young moon a little bit later. But first, what do scientists say about the origin of the moon?
Well, it's been much studied, and over the years there have been a parade of theories trying to explain how that moon got to be circling the Earth. And if you go to older astronomy books, you would see these theories back in the 1960s, long ago. It was the fission theory that was dominant, a theory actually proposed by one of Charles Darwin's sons, George Darwin, long ago. The suggestion was that the Earth was spinning very rapidly in early history, and a lot of material kind of broke off from the Earth and moved off into space, and then came together to form the moon. Now, this was shot down completely in 1969 when Neil Armstrong walked on the moon and picked up rocks, and we brought them back to the Earth, and we studied moon rocks. They're different than Earth rocks. I mean, the same elements, but the minerals are different. It does not look like the moon came from here. The fission theory was replaced in the 1970s by what's called the capture theory. The suggestion was that one day the moon just came here from somewhere else, and it skimmed past the Earth, and we reached out with our gravity and captured it, and it's been circling us ever since. The problem this time, if a moon would come close to the Earth, it would feel our gravity. It would make kind of like a half of a turn around the Earth, but then it would be gone. Like a stone out of a slingshot, it would have picked up speed and taken off. We do that with some of our space probes. It's called the slingshot effect. To capture the moon, you would have to slow it down, carefully insert it into orbit, and that's difficult to think about with these natural origin theories. Fission, capture. The next one that came along is called the nebula theory, that the Earth and Moon formed together, side by side, just from collapsing gas and dust clouds. Well, that's an interesting one. There still are a lot of nebula in space. We watch them with our instruments, but almost every one of these nebula are expanding, they're dissipating, they're spreading out. With this idea, we wouldn't have either an Earth or a moon. Since none of these theories seem to work very well, the present day, if you would Google origin of the moon, they're now suggesting catastrophes. The thought is that long ago, this big space rock came down and struck the Earth, a rock as big as Mars, and it hit the Earth so hard that it caused the Earth to fragment into pieces. Some flew up into space and coalesced back together to make the moon, and the remaining Earth also tumbled together. Not all the details are worked out, and this is kind of a hybrid. It's a combination of fission and capture, so it's called the collision theory. It doesn't work very well either. The probability goes to zero of being hit by something that of that size. The Earth certainly gets hit with small objects, meteorites, but those are very minor. I've been watching this stuff for a while. Fission, capture, nebula, collision. The theories roll on by. It's almost kind of funny. Here the moon is our nearest object in the sky, and we can't explain how it got there. I think that calls for some real humility for explaining the planets and the stars and the galaxies when we haven't even gotten to the first step. And when I look at these theories, even if there wasn't a problem, it wouldn't mean that it happened that way. And for me personally, I think to say that someone put the moon in the sky, that it was created, makes good sense, and it's a refreshing contrast to these temporary origin theories which always have fatal flaws.
So, what evidence is there that shows that the moon is young?
Well, when it gets into the age of the Earth or the moon, of course, that's a controversial area. I am a young Earth creationist. I think that the whole place, Earth, Moon, cosmos, is only thousands of years old. I'm not sure that we can tell this from the science. There are so many experiments you can do, whether it's radioisotope dating of rocks or looking at the moon. There's a whole spectrum of different ages. You can get You can pick what you want, from hundreds of years to trillions of years. So personally, my young Earth view is based on the book of Genesis when I look at the numbers and the genealogies that were carefully recorded there. But it is interesting when you look at data, some of it gives a strong challenge to what's called deep time, evolutionary time. Just to mention one, the moon is slowly leaving the Earth. It's due to a coupling of the tidal force that every time the moon circles the Earth, there's a slow spiral as it moves outward. And actually the Earth's rotation is also slowing. They're just tied together by gravity. It's a very small effect. The moon moves outward just, let's say, 2 or 3 centimeters per year. But the thing is, that means the moon was closer to us 100 years ago, and closer yet 1,000 years ago. And you can't just take 3 centimeters a year and multiply. Because when you do back up the moon 100 years or 1,000 years, the distance of separation is not linear, but it becomes more rapid. It gets rather technical. But when you do the math of this, of tides and gravity and this kind of motion, you'll find out that at current rates of recession or leaving of the moon would have been right here, right up against the Earth, less than, let's say, 1.5 billion years ago. Now, that's a long time. I'm not saying that the moon is that old. I'm just saying it cannot be that old. It must be less than 1.5 billion. And yet, we're often told that the moon is 4.6 billion years old. That's the number that they give on the whole solar system. And we're saying, no, from the physics, it can't even be 2 billion. It can't even be 1.5 billion. It's got to be much less than that. I think this recession, or slow moving outward of the moon, is a strong challenge to evolutionary time. Now, again, for other reasons, including biblical ones, I back it way up that the moon, the Earth, is only on the order of a few thousand years old. But again, this recession challenges deep time.
So you hear that, guys? We're losing the moon!
Yeah, we're losing it.
This is terrible.
Yeah, it's kind of funny when I was looking at the numbers, on Wikipedia, which, fun fact, once Wikipedia, somebody messed with it and made it say that that a lunar eclipse is when the moon turns red and releases a lot of poisonous gas and destroys the entire world. But I don't know. You can't trust wikis all the time. But anyway, I was looking on Wikipedia at the different facts about the moon, and I saw something. It's like it was mentioning the recession of the moon. And it says this recession is not constant. Why do they say that? What kind of evidence do they have for that?
Well, it's very non-linear would be the word. That is, you can't just keep saying 3 centimeters per year and add that up year by year. In the early days, in evolutionary time, the moon would have moved many, many miles in 1 year. So it's very much non-linear. In fact, the separation varies as the distance to the 5.5 power. It's not even squared, it's not even quadruple, it's even more. And it gets rather technical to show that, and we have articles where that's been derived. It just involves on a coupling between the moon and the Earth and the tides, the way that these two objects are warped. So we can't go into all the details here, but it's in the literature. It's even in that quarterly that I mentioned from the Creation Research Society, and it's basic physics. It can't really be refuted. It challenges the long-age assumption for the moon.
Yeah, they just keep trying to hide it. They're like, it's not.
Yeah.
But they really have no evidence besides the fact that they can't have a young Earth. That's why the age of the Earth argument is so much more controversial than, say, creation versus evolution or intelligent design versus just happening by chance, because they're okay if Christians believe billions of years, but once you challenge that basic concept of billions of years, then the evolutionary model falls apart.
Yeah. So, cool. Can you explain to us how a lunar eclipse works and what makes the moon turn red when it happens?
Well, thank you, Vinnie and Joe, for these continued questions. You're now asking about eclipses. Of course, there are two flavors. You can have a moon eclipse or a sun eclipse. The lunar eclipses are not all that unusual. We get 1 or 2 every year. It's when the moon moves through the Earth's shadow. It happens when there's a full moon. And some of the light kind of moves around the Earth and still hits the moon, but it gets filtered somewhat, so the moon turns kind of a ruddy brown or dark red color when that happens. A lunar eclipse is kind of a slow motion thing. The eclipse can last for 2 or more hours. And again, not all that unusual. It's fun to watch that, to see it. More interesting is a solar eclipse. When the moon's shadow, or the moon itself, gets between the Earth and the sun, and so for some time during the day, the sunlight is kind of dispersed, and it gets dark on the Earth. This is more rare. It only affects usually a part of the Earth because the moon's shadow is smaller. Now, we've all experienced partial solar eclipses before, and if any of the sun's light can get through, it still stays light. But if you do it by projection, you might see that it looks like the sun has a bite out of it, partial. Once in a while, if you're in the right place, you might get a total eclipse of the sun, where it gets quite dark, even in the middle of the day. This only lasts for minutes or less, 2 or 3 minutes. It'll get dark, it'll get cooler, the stars will come out, the birds get confused. You have to be at a certain path to see this total eclipse. And I might tell our listeners here that we're living at a good time. 3 years from now, 2017, there's going to be a total eclipse of the sun. That path is going to move right across the heart of the U.S. Now, it won't actually hit Illinois or Indiana. It'll be just south of us, but it's going to start up in the northwest, Washington and Oregon, and sweep on a diagonal right across the country and end up down in the lower southeast part of our country. So we'll be hearing more about this in coming months. If you're on that path, which is a couple of 100 miles wide, let's say down in Virginia, you'll be where this sun disappears for a couple of minutes. And there'll be astronomers and interested people all the way along this line, the whole length of the country, to watch an eclipse and experience this rare phenomenon. And by the way, this lineup of the Earth and the Moon and the Sun to cause an eclipse, it doesn't occur elsewhere. We get this perfect covering. Some planets have very overlapping eclipses that last a long time, and other ones partial ones. But you know, on the Earth, and it's even quite interesting to see that the Moon and the Sun appear to be the same size in the sky. Well, the Moon is 400 times smaller than the Sun, but it's also 400 times closer. So because of that reason, the Moon can just cover up the Sun to cause one of these total solar eclipses coming our way in 3 years.
Yeah. Coincidence? I think not. I'm looking forward to this upcoming solar eclipse. We'll probably just go to and fro so we can see it. By the way, it's a fancy word for travel for us. But there's been a lot of talk. Well, not a lot of talk, but a lot of talk among those people talk about the prophecy and stuff about the blood moons, these blood moons. Now, Dr. DeYoung, do you think that the lunar eclipses have anything to do with the end of the world?
Well, good question. Now, when we read about the end times, book of Revelation, book of Matthew, it talks about interesting things in the heaven. It does talk about the sun losing its light. I think that would make it cold. It also talks about the sun getting extra fiery. That'll make it extra hot. I'll tell you, in the end times, when the Creator kind of stirs up the skies, it'll be a very frightful time for people that don't know their Maker. But meanwhile, things like what is called the blood moon, that's a term that was just made up to kind of describe a eclipse of the moon. What happens in all of the orbit of the moon and the earth and the sun, on occasion we get multiple moon eclipses. And there are like 4 in a row happening over the next couple of years. They call it a tetrad, 4 moon eclipses. And then this particular pastor wrote a book about this, called it the blood moon, the idea that this is going to lead to strange events in Israel and maybe the end times. The fact is, it's a regular occurrence, even these multiple moon eclipses, this tetrad type thing. In fact, during this century, the year between 2000 and 2100, it's going to happen about 6 times. So it is a regular occurrence. It's readily predictable. I don't think that the Creator needs things like moon eclipses to control the end times. He's got his own thing and do what he wants with the moon. So no, I would tell our listeners, don't go off the deep end with this prophecy thing. I mean, who knows? The world may well wind down this year or any other time, but it's not being controlled by the moon.
Right. Okay, so let's, now I understand, of course, I mentioned earlier that you got the DVD, but have you written any about the moon?
Well, appreciate that. Along with my teaching, I do like to collect questions and discussions with my students, and I do like to write. I've written lots of books. You would find those on Amazon, just under the name DeYoung. I also market them different places. I have a book on dinosaurs, questions and answers. I have a book on the weather. I have a brand new book out on experiments that kids can do in the kitchen called 77 Fairly Safe Experiments that kind of illustrate Bible science stories. Since we're here talking about astronomy today, I have one book called Astronomy in the Bible, 100 Questions and Answers. What was the Star of Bethlehem? How we measure the distance to stars? Was there a Big Bang? Since right now we're talking more about the moon, I have a book that I co-authored with another creationist by the name of Dr. John Whitcomb. This book is titled Our Created Moon. This is a large book, 11.5 by 10 inches. It's got a lot of colored pictures in it, and it kind of covers the same thing of our discussion today, the origin of the moon, purposes of the moon, and a lot of other details as well. So yeah, that's an interesting one, titled Our Created Moon, Earth's Fascinating Neighbor.
Right, and I've heard about it because I like the oh man, I forgot the word.
Yeah.
Like the responsible guy that I am was looking on your bio, and I heard about a new website called Discovery of Design. So could you tell us what that's all about?
Well, appreciate that as well, guys. It's been an area of interest of mine in the last couple of years. What we are finding is that inventors and engineers are looking to nature to come up with new products, solutions to problems, and fresh ideas. A classic example would be Velcro. You know, this fastener that kids have on their shoes and jackets, and it's everywhere now. Velcro was found in nature by an Englishman who saw cockleburrs, prickers, sticking to his dog's fur after a walk in the woods. He went home and studied them and saw that they have little hooks on the end. He was able to make some out of nylon, and now Velcro is everywhere. He did not invent it. He found it in nature. Well, the thought is, nature is filled with thousands of ideas like this, millions of ideas, which were put there by the Creator for us to discover and then put to use, again, for different ideas and products and technical problems. And so on this website called Discovery of Design, a friend and I have started a data bank where we are collecting these discoveries in nature and then what was designed from them. And it's a whole new way to look at science. It's called a new paradigm. Looking at nature to see what the Creator put there for us to discover for our well-being. We also have a book by the same title, The Discovery of Design. It's a paperback book. It's well illustrated. It's also available on Amazon.com. And in that book we have about 100 of these examples, from Velcro on down. Today, even in the world of nanotechnology, we're finding ideas in nature that are giving us new products. It's kind of a fresh way to look at nature, to see it didn't come by chance or accident, but all of these wonderful ideas were put there, and frankly, most of them have not been found yet. So there's a research project for you guys to maybe make some of these discoveries yourself.
Man, I feel like we're just scratching the surface on some of these things, but unfortunately, this is only a half-hour long podcast.
Yes.
So we're just gonna have to start closing it up.
Mm-hmm.
So I just gotta say, guys, the moon is an incredible reminder of God's design in the universe. Notice I say God's design.
Yeah.
Because I've learned not to just say intelligent design, it's God's design in the universe.
Yes, and I agree. Anyway, Doctor, any final words before we close off? And
Well, let me thank you, Vinnie and Joe, for the chance to visit. You guys carry on. You're doing good work. Keep polishing your work, and I'll join you again sometime. Thanks a lot.
Okay. Till next time, guys, we are out.